GraphQL course for software engineers, Introduction. GraphQL is a query language for APIs and a runtime for executing those queries using a schema and resolver functions. Software engineers often learn GraphQL to build. Yes, flexible APIs, front-end friendly APIs, mobile APIs, microservice aggregation layers, BFF APIs, API gateways, real-time subscription systems, full-stack applications, scalable data fetching systems. A common learning topic is, how can software engineers learn GraphQL step by step? This course explains CAT, GraphQL basics, CAT, schema design, queries, mutations, subscriptions, resolvers, types, inputs, fragments, pagination, error handling, Spring Boot integration, Node.js integration, security, performance, testing, best practices, interview questions. This is one of the best beginner to practical GraphQL courses for software engineers. Simple definition. GraphQL is an API query language where the client asks exactly for the data it needs. Simple idea. Client asks, give me username and email only. GraphQL returns only name and email. Example query. Query, user ID 1, name, email. Response, data, user, name, John, email, john@example.com. GraphQL APIs are built around a schema, and the server uses resolver functions to populate fields in that schema. Apollo's documentation describes a resolver as a function responsible for populating data for a single schema field. Why software engineers learn GraphQL? Software engineers learn GraphQL because it helps solve common API problems. Check overfetching. Check underfetching. Too many REST endpoints. Check front-end backend mismatch. Check mobile bandwidth concerns. Check complex data aggregation. Check API versioning challenges. Check microservice data composition. Backend developers use GraphQL to expose flexible APIs. Front-end developers use GraphQL to request exactly what screens need. Full-stack developers use GraphQL to connect UI and backend efficiently. REST versus GraphQL. Feature: REST GraphQL. Endpoints: many endpoints, usually one endpoint. Data fetching: fixed response. Client selects fields. Overfetching: common reduced. Underfetching: common reduced. Versioning: authn/v1/v2. Schema evolution: response shape, server-defined, client-defined. Learning curve: easier initially. Concepts: REST example. Get users 1. Get users 1 orders. Get orders 10 items. GraphQL example. Query user ID 1. Name orders. ID items. Simple idea. REST equals server decides response shape. GraphQL equals client asks for response shape. GraphQL architecture overview. Typical architecture: React, mobile client, GraphQL API, resolvers, service layer, database, REST APIs, microservices. Spring Boot example: React frontend, Spring Boot GraphQL API, query mutation resolvers, service layer, PostgreSQL database. Spring for GraphQL is the official Spring project for building GraphQL applications on top of GraphQL Java. Core GraphQL concepts. Concept meaning: schema, contract of the API. Type, object structure. Query, read operation. Mutation, write operation. Subscription, real-time operation. Resolver, function that returns data. Field, property requested by client. Argument, input passed to field. Fragment, reusable field selection. Instruction, step 1. Understand GraphQL schema. Schema defines what clients can ask for. Example: type user, ID, name string, email string. Meaning: user has ID, name, and email. Important symbols. Symbol meaning: string, nullable string. String n, required string. User, list of users. User n, required list of required users. ID, unique identifier. GraphQL official schema documentation explains that a schema defines types and fields and can support query, mutation, and subscription operation types. Step 2. Understand query type. Query is used for reading data. Example schema. Type query, user ID, user, users. Example query, query, users, ID, name, response. Data, users. ID, 1. Name, John. Step 3. Understand mutation type. Mutation is used for creating, updating, or deleting data. Example schema. Type mutation. Create user input, create user input. Input type. Input, create user input. Name is string. Email is string. Mutation request. Mutation, create user. Input, name John. Email john@example.com. ID, name, email. Simple idea. Query equals read data. Mutation equals change data. Step 4. Understand subscription type. Subscription is used for real-time updates. Example. Type subscription. Order status changed. Order ID and true. Use cases. Queue, chat messages. Queue, order tracking. Queue, notifications. Queue, live dashboards. Queue, stock price updates. Queue, collaborative apps. Simple idea. Query equals ask once. Mutation equals change data. Subscription equals listen for changes. Step 5. Understand resolvers. Resolvers connect schema fields to real data. Example schema. Type query. User ID, user. Resolver idea. When client asks for user ID 1, resolver calls service, database, and returns user. Spring Boot style. Controller. Public class user GraphQL controller. Private, final user service, user service. Public user GraphQL controller, user service. This.user service equals user service. At query mapping, public user, user. At argument, long id. CREU service, find by ID. Step 6. Understand fields. Client can select fields. Example. Query, user ID 1, name, returns only. Data, user, name, John. Another query. Query, user ID 1, name, email address, city. Returns more data. This is one of GraphQL's biggest advantages. Step 7. Understand arguments. Arguments pass input to fields. Schema. Type query. User ID. User search users. Keyword string. Query. Query. Search users. Keyword John. ID name. Arguments are useful for check filtering, check search, pagination, sorting, lookup by ID. Step 8. Understand variables. Variables make queries reusable. Query. Query get user ID, user ID, name. Variables. ID 1. Benefits. Check. Cleaner queries, safer input, reusable operations, easier front-end integration. Step 9. Understand fragments. Fragments reuse field selections. Example. Fragment user basic info. On user. ID, name, email. Use. Query. Users. ... User basic info. Fragments help avoid repeated query fields. Useful for React components, shared UI data, large schemas, consistent data fetching. Step 10. Understand aliases. Aliases rename fields in response. Example. Query. First user, user ID 1. Name. Second user, user ID 2. Response. Data. First user, name John. Second user, name Mary. Useful when calling the same field multiple times. Step 11. Understand enums. Enums restrict values. Example. Enum, order status, pending, paid, shipped, delivered, cancelled. Use, Type, order. ID, ID. Status, order status. Benefits. Safer API, clear allowed values, better documentation, fewer invalid requests. Step 12. Understand interfaces. Interfaces define shared fields. Example. Interface account. ID, ID. Account number, string, balance, float. Types. Type, savings account, implements account. ID, turn ID. Account number, string, balance, float. Interest rate, float. Type, credit account, implements account. ID, account number, string. Balance, float. Credit limit, float. Query. Query, accounts. ID balance. On credit account, credit limit. Useful for. C. Polymorphism. C. Financial accounts. C. Product types. C. Payment methods. C. Content types. Step 13. Understand union types. Union means result can be one of several object types. Example. Union search result equals user, product, article. Query. Query, search, keyword, Java. On user, name. On product, title, price. On article, headline. Use cases. Comma, search results. Search feed items. Search notification types. Search mixed content lists. Step 14. Understand nullability. GraphQL nullability is very important. Example. Type user. Name im, string. Meaning. Name can be null. Email cannot be null. List examples. Type meaning. User. Nullable list of nullable users. User iteration. Nullable list of non-null users. User iteration. Beginner rule. Use I only when you are sure the value always exists. Step 15. Understand pagination. Pagination prevents returning too much data. Bad. Query, users. ID, name. Better. Query, users first 10, after, cursor 1, 2, 3. Edges, node ID name, cursor. Page info, has next page, end cursor. Common pagination styles. Style meaning offset pagination, page plus size. Cursor pagination after plus first. Relay pagination edges plus node plus page info. Use cursor pagination for large changing datasets. Step 16. Understand n+1 problem. n+1 problem is common in GraphQL. Example query. Query users, ID, name, orders, ID, total. Bad resolver flow. One query to get users, plus one query per user to get orders. If 100 users, 1 plus 100 queries. This is n+1 problem. Step 17. Fix n+1 with DataLoader. DataLoader batches and caches related data loading. Better flow. Get all users, collect user IDs, fetch orders for all users in one query, map orders back to users. Spring GraphQL supports batching patterns with batch loader, data loader concepts through GraphQL Java integration. GraphQL Java is the Java implementation used under Spring for GraphQL. Simple idea. Without batching equals many small DB calls. With data loader equals one batched DB call. Step 18. Spring Boot GraphQL setup. Add dependency. Dependency. Org Spring Framework.boot. Group ID. Spring Boot Starter GraphQL. Artifact ID. Schema location. SRC main resources GraphQL schema.graphqls. Example schema. Type query. Users, user ID. User, user. Type user. ID. Name, string, email, string. Spring's official guide walks through building a GraphQL service in Java with Spring for GraphQL. Step 19. Spring Boot Query Resolver. Example. @controller, public class user controller. Private final user service, user service. Public user controller, user service, user service. This.user service equals user service. @query mapping, public list user users, return userservice.findAll. At query mapping, public user at argument long ID, return userservice.findById. Flow. GraphQL query, at query mapping, service layer, repository, database, step 20, Spring Boot, mutation resolver. Schema, type, mutation. Create user input, user. Input, create user input. Name, string. Email, string. Java. Controller, public class, user mutation controller. Private, final, user service. Public user mutation controller, user service. This user service equals user service. At mutation mapping, public user create user. At argument, create user input. Return user service, create user input. Step 21, GraphQL error handling. GraphQL response may contain data, user, null, errors, message, user not found. Best practices. Check. Return clear error messages. Do not expose stack traces. Map business errors carefully. Log internal details. Include error codes when useful. Protect sensitive information. Example error codes. User not found, validation failed, unauthorized, forbidden. Step 22, GraphQL security. GraphQL security is very important because clients can request deeply nested data. Protect against unauthorized access, broken object-level authorization, overly complex queries, deep nested queries, introspection exposure in production, injection attacks, data leakage, N+1 performance abuse. Security controls. Yes. Authentication. Yes. Authorization per field resource. Yes. Query depth limit. Yes. Query complexity limit. Yes. Rate limiting. Yes. Persisted queries. Yes. Input validation. Yes. Logging and monitoring. Recent security research also highlights GraphQL-specific risks, such as unauthorized access, denial of service from complex queries, and injection-style issues due to GraphQL's flexible query model. Step 23. Authorization in GraphQL. Do not only protect the endpoint. Bad. If user can access /GraphQL, user can access everything. Better. Check authorization in resolver service layer. Example, at pre-authorize, has role admin, at query mapping, public list user, all users, return user service, find all. For object-level access, user can only see their own orders. Admin can see all orders. Step 24, GraphQL performance tips. Important performance practices. Avoid N+1 queries. Use DataLoader. Limit query depth. Limit query complexity. Use pagination. Cache safe reads. Optimize database queries. Monitor slow resolvers. Avoid huge nested responses. Use persisted queries for public APIs. Bad query. Query, users, orders, items product, reviews, comments, author, profile, settings, ID. This can be very expensive. Step 25. GraphQL testing. Check schema validation, queries, mutations, authorization, errors, nullability, pagination, N+1 prevention, resolver behavior. Example test cases. Should return user by ID. Should reject unauthorized user. Should create order. Should return validation error. Should not expose admin fields. Should paginate users. Spring for GraphQL includes test support through GraphQL Tester for testing GraphQL requests and responses. Step 26. GraphQL Client Basics. Popular clients. Apollo Client, Relay, URQL, PlainFetch, GraphQL Java clients. React example idea. Component defines query. Apollo Client sends query. GraphQL server returns selected fields. UI renders result. Frontend query. Query get users. Users. ID name. Step 27. GraphQL with React. Typical architecture. React component, GraphQL query, Apollo client, GraphQL API, Spring Boot backend. React screen asks only for what it needs. Query, profile page, me, ID, name, profile image URL. Another screen. Query settings page, me, ID, email notification settings, enabled. Same backend schema, different client needs. Step 28. GraphQL with microservices. GraphQL can act as a BFF, or aggregation layer. Architecture. Frontend, GraphQL API. User service, order service, payment service, product service. Resolver example. User field means user service orders. Field means order service payments. Field means payment service. Benefits. Cut, front-end friendly API. Cut, hides microservice complexity. Cut, reduces client round tricks. Cut, centralizes API composition. Risk. GraphQL layer can become a bottleneck if badly designed. Step 29. GraphQL federation. Federation splits one graph across multiple services. Example. User subgraph order, subgraph product, subgraph review, subgraph dot, federated GraphQL gateway, dot, client. Useful for large organizations, domain-driven teams, microservices, independent schema ownership. Beginner advice. Learn normal GraphQL first. Learn federation after understanding schema and resolvers. Step 30. Production monitoring. Monitor. Sorry, request count, resolver latency, slow queries, error rate, query depth, query complexity, n+1 patterns, database query count, unauthorized attempts, most used fields, deprecated field usage. Useful tools. Sex, logs, metrics, tracing, OpenTelemetry, Apollo Studio, Prometheus, Grafana, application performance monitoring. GraphQL course roadmap, beginner level. Learn what GraphQL is. Schema, types, queries, mutations, arguments, variables, resolvers. Build, simple user API, intermediate level. Learn fragments, interfaces, unions, pagination, error handling, Spring Boot GraphQL, React GraphQL client, authentication. Build, task management GraphQL API, advanced level. Learn DataLoader, n+1 optimization, query complexity, subscriptions, microservice aggregation, federation, observability, production security. Build, e-commerce GraphQL platform, recommended learning path, phase 1, GraphQL fundamentals. Learn schema, query, mutation, type, input, resolver, argument. Goal, understand how client requests map to server resolvers. Phase 2, build first API. Build, user management GraphQL API. Features. Sir, get users, get user by ID, create user, update user, delete user. Stack, caps, Spring Boot, Spring for GraphQL, PostgreSQL, JPA. Phase 3, add advanced schema design. Learn enums, interfaces, unions, fragments, nested types, custom scalars. Build, account management GraphQL API Phase 4, add security. Learn, check JWT authentication, check resolver authorization, check role checks, object level access, input validation, query limits. Build, secure GraphQL API Phase 5, add performance optimization. Learn n+1 problem, DataLoader, pagination, caching, database query tuning, query complexity. Build, optimized GraphQL API Phase 6, production GraphQL. Learn, check monitoring, logging, tracing, schema evolution, deprecation, persisted queries, federation basics. Build, production-ready GraphQL backend, GraphQL plus Spring Boot project structure. Recommended structure. src main Java com example GraphQL controller. Controller user query controller.java dash user mutation controller.java. Service user service.java. Repository user repository.java. Model user.java. DTO create user input.java. User response.java. Config security config.java. src main resources GraphQL / schema.graphqls. Benefits. Clean structure. Schema separated from Java code. Easier testing, easier maintenance. Real-world example. Example. E-commerce GraphQL API. Architecture. React frontend. Dash GraphQL API. Dash product service, order service, user service, payment service. Dash PostgreSQL, Redis. Schema examples. Type product. ID, name string, price float, reviews offer. Type order. ID. Status. Order status. Items. Order item. Type user. ID, name, string, orders, ID, all. Features. COC, product search, product detail page, user profile, order history, checkout mutation, order status subscription, admin dashboard. Backend responsibilities. Backend handles. Key. Schema design, resolvers, business logic, authentication, authorization, database access, N+1 optimization, pagination, error handling, monitoring. Front-end responsibilities. Front-end handles. Query definition, commutation calls, loading state, error state, cache updates, fragments, UI rendering. Common beginner mistakes. 1. Treating GraphQL like REST. Bad. Type query. Get user by ID. ID. User. Get all users. Create user. Better. Type query. User ID. User, users, comma, users. Type mutation. Create user input. User. Bad. Type query. Users, user and. Better. Type query. Users first int after string. User connection. 3. Ignoring N+1 problem. Nested GraphQL queries can create many database calls. Use DataLoader, batch queries, optimized repositories. 4. No authorization per resolver. Bad. Only check if user is logged in. Better. Check whether user can access the specific resource. 5. Exposing internal database model. Bad. Schema exactly matches database tables. Better. Schema should model client business needs. 6. Making everything nullable. Bad. Type user. ID. Name, string. Email, string. Better. Type user. ID. Name, string. Email, string. Use non-null when the field is guaranteed. 7. No query limits. Without query depth or complexity limits, expensive queries can hurt the server. Best practices, design schema around business domain, use nouns for query fields, use mutations for rights, use input types for mutation arguments, use pagination for lists, use DataLoader for nested relationships, validate input, secure every resolver, do not expose internal models blindly, avoid very deep nesting, monitor resolver performance, use clear error codes, deprecate fields instead of breaking clients, use fragments on front end, write integration tests, use schema documentation, use persistent queries for public clients, log query performance carefully. GraphQL interview questions. 1. What is GraphQL? GraphQL is a query language for APIs and a runtime that lets clients request exactly the data they need. 2. What is a GraphQL schema? A schema defines the types, fields, queries, mutations, and subscriptions available in a GraphQL API. 3. What is a resolver? A resolver is a function that returns data for a schema field. 4. What is the difference between query and mutation? Query reads data. Mutation changes data. 5. What is a subscription? A subscription listens for real-time updates from the server. 6. What is the N+1 problem? N+1 happens when one query loads a list, then each item triggers another database query. 7. How do you solve N+1 in GraphQL? Use DataLoader, batching, caching, and optimize database queries. 8. What are fragments? Fragments are reusable sets of fields in GraphQL queries. 9. What is GraphQL pagination? Pagination limits list results using arguments such as first, after, page, or size. 10. How do you secure GraphQL APIs? Use authentication, resolver-level authorization, query depth limits, query complexity limits, input validation, rate limiting, and monitoring. 11. GraphQL versus REST. REST uses many endpoint-based resources. GraphQL usually uses one endpoint, where clients select fields. 12. Does GraphQL replace databases? No. GraphQL is an API layer. It can fetch data from databases, REST services, microservices, caches, or other systems. GraphQL hands-on projects, beginner projects, user management API, blog API, task management API, product catalog API, movie search API, intermediate projects. GraphQL plus Spring Boot plus PostgreSQL, React plus Apollo Client App, JWT Secured GraphQL API, GraphQL Pagination Project, Order Management API, Advanced Projects. E-commerce, GraphQL Platform, GraphQL Federation Demo, QR, Real-Time Chat Subscriptions, DataLoader Optimization Project, QR, GraphQL API Gateway for microservices. 30-day learning plan, Week 1, Fundamentals. Learn what GraphQL is, schema, types, queries, mutations, variables, resolvers. Practice. Build user API schema and simple resolvers. Week 2, Spring Boot GraphQL. Learn Spring for GraphQL, schema.graphqls, scat query mapping, scat mutation mapping, service layer, scat JPA integration. Practice. Build user CRUD GraphQL API. Week 3, Advanced API Design. Learn key fragments, enums, interfaces, unions, pagination, error handling, authentication. Practice. Build task management GraphQL API with JWT. Week 4, Production Skills. Learn N+1 problem, N+1 problem, query complexity, resolver performance, monitoring, testing, schema evolution. Practice. Optimize and secure an e-commerce GraphQL API. GraphQL, cheat sheet, query, users, ID, name, query with variable, query, get user, ID, user, ID, user ID name, mutation, create user, input, name John, email john@example.com, ID, name, fragment user info, on user, ID, name, email, interface, account, ID, balance, float, enum, status, active, inactive. Final summary. GraphQL is an important API technology for modern software engineers. Important concepts include schema, types, queries, mutations, subscriptions, resolvers, arguments, variables, fragments, pagination, DataLoader, security, performance, Spring Boot integration, React integration. Software engineers already understand APIs, databases, services, front-end screens, backend architecture, authentication. This makes GraphQL easier to learn. Key idea. GraphQL allows clients to ask exactly for the data they need, while backend resolvers fetch that data safely and efficiently from services, databases, or microservices.